factoring introduction. We want to be able to factor. And the word factor means to write as multiplication. So for example, suppose I had the number 30. If I were to write the number 30 in factored form, I'd write it in multiples. For example, 5 times 6. Or in other words, 5 times 2 times 3. That we refer to as the prime factorization. The prime factorization. Now we can deal with numbers in that way, it's no big deal, but what about algebraic expressions? They too can be factored, and we always start with this thing called a greatest common factor. A greatest common factor. From there we have different things such as difference of squares, maybe you've heard about that. Maybe you've heard about trinomials that we've used before. Some are difference of cubes. These are all things that we use for factoring. And so we have got a bunch of branches we kind of look at and some different formulas that we're going to share with you later on. But right now we're going to practice the very basic one, which is just this general factoring technique. And we are first going to look at difference of squares. Who can tell, or I'm sorry, greatest common factor. What is the greatest common factor that you can take out of 10x and 18? What are they both divisible by? 2. So as you factor that out, you're left with 5x, because 2 times 5x is 10x. And then you have 2 times 9 is 18. And that's my factoring using my greatest common factor. Sometimes you can not just factor out numbers, but you can also factor out variables. My common factor is 2.
Attention staff and students, we are now in a hold. Again, staff and students, we are now in a hold. If you are in the hallway, please locate to the nearest classroom. Thank you.
And what can I take out for variables?
X squared.
X squared. And then you're always asking yourself this question. 2x squared times what is 12x to the 4th? 2x squared times 6x squared, right? And 2x squared times what is 2x cubed? X. And 2x squared times what is 6x squared? 3. That's that. I want you to try example 3 on your own. This one has a little trick to it. I want to see how it goes for you. You can factor out the 2. Should I have the top one as my answer or the bottom one as my answer? The bottom one. A lot of times when people see that they take out a 2, they're like, oh, the 2's gone. You can always check your answer by distributing back through. Notice how 2 times 2x cubed is 4x cubed, and 2 times 1 is 2, and 2 times 3y cubed is 6y cubed. If you didn't have the y minus 1 in there, then you couldn't come up with the negative 2 as you multiply back through. So that is not correct. It's your bottom one. Very good. Okay, flip it over. Sometimes it's tough to tell what the greatest common factor is. For example, if you look at 80 and 48, what number do you feel like 80 and 48 are both divisible by?
8.
So let's do 8. In fact, we'll take out an 8 and an x. And I'm left with 10y and a minus 6x. And that looks fine, except when you look at your final answer, is there a common factor you could take out a 10 and 6? Yeah, you could take out 2. So we're not done. We need to take out 2 again. And when you factor out the 2, it would be 2 times 8 is 16. So you can factor it again. It turned out that 80 and 48 were both divisible by 16. That's not a number that everybody generally remembers.
Again, the whole is all clear.
Then finally, in this example, if you have a negative in your lead term, you should start by taking out that negative as well as the rest of the common factor. So I'm going to factor out a negative 5d. And notice how it's going to switch this negative 5d squared to a positive d. And then the positive 15d is going to switch to a negative 3. That's greatest common factor. Another way of factoring is factoring a trinomial. Trinomial because it has 3 terms to it. Notice how there is no greatest common factor. Nothing, there isn't anything I could take out of each piece. So it turns out it factors, we kind of saw this yesterday, it factors to 2 binomials. X times x is x squared. What are the 2 numbers you multiply together to get negative 15 that add a positive 2? Positive 5 and negative 3. Tell me, is that the same as x minus 3 times x plus 5? Yes. Is that the same as x minus 5 times x plus 3?
No.
These 2 are the same. That one's not, because that would produce a negative 2x in the middle. So you could take your terms that you're multiplying and put them in a different order, but your pluses and minuses, they do matter. When people see a 6 and a 5, they often think of 3 and 2. So I factor this to x plus 3 times x plus 2. Is that correct? No, it's not. Why is that incorrect? Yeah, 3 times 2 is 6. And 3 plus 2 is 5. I've got it backwards. So what are the 2 numbers that multiply to 5 that add to 6?
5 and 1.
Just 5 and 1. Okay? So be careful to check. I'm trying to show you guys the mistakes that people make. Please try example 9, 10, 11, and 12 on your own. 9, 10, 11, 12. Here's how those factor, and x plus 8 times x plus 8. Does anybody know another way I could write this?
X plus 8 squared.
Yes, that quantity squared, and x minus 1, that quantity squared. Very good. Another method of factoring is by factoring the difference of squares. I'm sorry that I have these so close to the problem number, but this is x squared minus 1. And it factors just like a trinomial again. What's different about this is there's no middle term. So I need the two numbers that multiply to -1 but add a 0. And those are obviously +1 and -1. And that's what makes the difference of squares so easy, is that you have the same number on the end. It's just one is plus and one is minus. So x squared minus 9 will be x plus 3 times x minus 3. X squared minus 196. This doesn't really work out unless you recognize it's a perfect square. Does anybody know what 196 is as a perfect square? What number do you square to get 196?
13.
Close. 13 squared is 169. 14 squared is 196. This is plus 14 and minus 14. Number 16 is 4x squared minus 81. Yes, you can have a number in front. These are both perfect squares. What do you multiply by itself to get 4x squared? Two x and 2x, and then plus 9 and minus 9. We're not going to do number 18, but we are going to do 17. As you consider problem 17, sometimes as you look, you realize that even before you factor the difference of squares, because these are both perfect squares, you can see that sometimes there's a common factor you can remove right away. And this is always what you should do first. What is the common factor that divides both evenly into 100 as well as 36?
10.
It is, the square root of 100 is 10, and the square root of 36 is 6. But what is the number that divides evenly into both of them? They're both divisible by 4. If I take a 4 out of 100 x to the fourth, what do you get? 25. And if you take a 4 out of 36, what are you left with? 9. I still have the difference of squares, don't I? So I'm going to factor it again. This is a two-step factoring problem. I have a 5x squared and a 5x squared. I have a plus 3 and I have a minus 3. And there's your factoring. Which brings us to this. We're now ready to put it all together for a factoring completely. We'll do about half these problems. We'll give you guys time to work. I'll show you the specifics of your assignment you want to work on. But every time you go to factor something completely, which is generally what we're trying to do, is you always look to remove the greatest common factor first. And what is your common factor? 2. And you're left with x squared plus 5x plus 6. Does that factor? Yes. We have an x plus 3 and an x plus 2. And now I'm done. So notice the 2 steps in factoring. Problem number 20. I can factor out a 3. I'm left with x squared minus 25. I notice that x squared minus 25 is the difference of squares. I have x plus 5 times x minus 5. What's the common factor for 21? X. I'm left with x squared plus x minus 15. This now factors as a trinomial. 2 numbers that multiply to negative 15. Whoop, I forgot the 2. I did that last hour as well. 2 numbers that multiply to negative 15, they add a positive 2. Positive 5 and negative 3. We're only going to do 2 more here. I want to look at number 24, and I want to look at number 27. What's the common factor for 24?
Five.
5x. When you take out 5x, you're left with 5x squared. Does anybody know 5 times what is 90?
18.
It is 18. And 5 times what is 40? 8. Now notice that this is something that we haven't seen yet. There's a number in front of the x squared, and you can't take it out by removing a common factor. And so we need to multiply to 5x squared. So I'm going to have a 5x and an x. And now I have some options for -8. I could have a -2 and a +4. I could have a -8 and a +1. I could have a -4 and a +2. Anybody have some thoughts on how I might choose there? None of them add to -18. That rule doesn't work when you have a number in front like that. Do you want to make a guess? What do you think?
It's 2 and then -4.
It's a 2 and a 4, you say,
But the positive.
and you're saying that this is positive and this is negative?
Yeah.
Well, here's how we check. And by the way, folks, we spent a day going over these type of problems because this ends up generally being challenging for people to work through. So we're going to show you some strategies there. But as we check right here, notice as we check the inside and the outside to see if we come up with this middle. We have a 2x and we have a -20x. And you can see that that does make a -18x. So therefore, this is the correct factoring. But a lot more challenging when you have a number in front. That changes things. Our last example we do is 27. What is the common factor for 27? Yep, I can take out an 8 and an x to what power? 5. When I take that out, I have just an x squared that's left, and it's -4. And now we can see I have the difference of squares. So 8x to the 5th, and an x plus 2, and an x minus 2. And that is now factored. So we're going to spend a couple days on factoring, kind of catch up on some previous skills. As you look at your homework is a little bit different. It's organized in a different way from what it normally is, okay? Notice on this front page right here, it says factoring completely. That's not what I want you to start on right now. Eventually, you'll look at the factoring completely thing. If you turn it over, here's some problems that say level 1. That would be the easiest type of factoring problem. So if you're a person like you say, hey, you know what? I need to review the basics of factoring. Then choose level 1. The next one's level 2. That's a little bit more challenging, okay? Not too bad, but a little bit more challenging. And then finally, level 3 is the most challenging. I need you to choose 2 out of those 3 levels. So you don't have to do all of them. You could choose to do all of them if you want, but either do 1 and 2, or do 2 and 3, or do all of them. You get to choose based off of kind of where you feel like you're at. The answer key for those is posted right here. Okay, and don't feel bad if you're like, you know what, I need to try some of level 1 because I don't remember all my factoring methods, okay? See what you can do there.